Hello everyone. In engineering workshop, so far we have discussed so many manufacturing process like casting, welding, forming. In today's session, we are going to discuss about machining and boring. Now, what is machining process? Machining is one of the manufacturing process where we get accurate shape of the components. With the accurate shape can also be obtained in casting. But what is the difference between machining and casting process? In a casting process, the amount of defects that are obtained are much higher and the surface is not that smooth. Whereas in a machining process, we can get the desired surface finish on the component. And this process can also be called as a material subtraction process, since in this process we remove the material to get the final shape of the component. And coming to the classification of this material removal process, these are classified into conventional machining and unconventional machining. Like here you can see, conventional machining is nothing but a process in which a hard tool is used to machine or to get the removal process, material removal process. Whereas in a non-traditional machining or unconventional machining process, the material removal can be obtained even by using a softer tool. That is the main difference between a conventional machining process and an unconventional or a non-traditional machining process. And there are other differences between conventional and non-traditional machining process. Like if you see, in a conventional machining process, there is always contact. The tool and the workpiece are in contact while the material removal is happening. Whereas in an unconventional or non-traditional machining process, there need not be a contact between the tool and the workpiece. The material removal can happen without the contact between the tool and workpiece. Now, for example, if you take electrical sparks, like when the sparks fall on an electrical wire, due to the fall of the electrical wire or due to the contact of those electrical sparks on the wire, the material is lost from the workpiece surface or the wire surface. Now, this is happening, now the electrical energy is removing the material. And also, like if you take another example, that is by using chemicals. If you want to remove the rust from any surface, any workpiece surface, if you put it in a chemical solution, like for example, if you take the basic, like if you want to remove the oxide layer from the silver, components, you just keep it in a tamarind water. Then you can, after some time, there will be a reaction, chemical reaction occurring between the silver silver metal and the tamarind pulp, and there will be a material loss from the surface, that is the oxide layer will be lost from the surface. So that also comes under non-traditional machining process, where we don't use directly the energy to remove the material or to remove the material from the surface of the workpiece. Now those comes under the chemical machining process, and whatever we have discussed, the wire removal of material from the wire surface, that comes under thermal way of material removal process. And there are other process like electrochemical machining process, like where we use both electrical energy and chemical energy. Like the best example is electrolysis process. By using an electrolysis process, you can remove the material from anode surface by using a cathode, when both are placed in an electrolyte which acts as a solution medium for the removal of the material. So in that way, in non-traditional machining process, not only mechanical energy, we can also go for other types of energy. We can also use different types of energies to remove the material from the surface. Here the tool which is used is softer when compared to the workpiece, right? So here, in a non-traditional machining process, not only mechanical energy but also different types of energies can also be used to remove the material from the surface. Whereas in a conventional machining process, we use only mechanical type of energy to remove the material from the surface. That is one of the difference between conventional and non-traditional machining process. And also, mm, if you take the amount of force that is developed in these two processes, like if you take the conventional machining process, where in a conventional machining the amount of force that is developed during the process is much higher when compared to non-traditional machining process. This is happening because there is a contact between the tool and the workpiece. Because of the contact between the tool and workpiece, the amount of force that is produced in a conventional machining process is much higher than compared to non-traditional machining process. But at the same time, if you take the amount of material removed in a conventional machining process is much higher when compared to non-traditional machining process. And there are other types of material removal process, like here you can see the abrasive process by using abrasives. Like for the most or the best example for this process is grinding process, where we grinding wheel on a grinding wheel. Like for example, if you take the stone, you have a knife at your home, and if you have to sharpen that knife, you use a stone. Now that stone consists of hard particles on it. Now these hard particles are nothing but the abrasives. Those are nothing but the abrasive particles. They are all bonded together to form a stone-like structure. Now grinding is the same process where in which these hard abrasive particles like aluminum oxide, boron carbide, silicon carbide and diamond particles, these particles are bonded together to form a wheel, where that is used to remove the material from the surface, where each particle on this surface will be acting like a single point cutting tool. Now we'll be discussing about what is this single point cutting tool and all when we go for the classification of different types of tools which we use for the machining process. Right? So for now, the machining process or the material removal process is classified into conventional machining, abrasive process like removal of material by using abrasive particles, and non-traditional machining process. Now, in a conventional machining, we use different types of tools. Like we use a tool which has a single point cutting tool, a multi-point cutting tool, or a two-point cutting tool, two cutting edges. Now, when do we call this? What are the different types of cutting tools? If you see this, now in the first process, like as we have discussed, there are single point cutting tool and multi-point cutting tools. Now if you take a single point cutting tool, in a single point cutting tool, how do we define this single point cutting tool? Now we define a single point cutting tool based on how many cutting edges it has. Like if you see, if it has a single one cutting edge which will be participating in the material removal process, then we call this tool as a single point cutting tool. Whereas a multi-point cutting tool is which will be having multiple cutting edges. During the machining process, the number of cutting edges which will be participating in the machining will be more than one, more than two, more than then that is called as a multi-point cutting, where Now if you see, this is a basic single point cutting tool where it has one single cutting edge and a tool nose point radius is present and a rake face is present, tool shank is present, and flank. These are the different terms which we use or which we use to define a single point cutting tool. Now, if you take the cutting edge, how do we define the cutting edge? Cutting edge is nothing but it is the one which will be participating in the material removal process, in the machining process. Whereas rake face is the one on which the chip will be moving, or after the material is removed, the chip will be traveling from this surface or moving on this surface. That is a rake face. Whereas if you take flank is nothing but the part which supports the cutting edge at the bottom, which lies below the cutting edge is termed as a flank. And if you take tool shank is nothing but the one which will be supporting this cutting edges, this part. Now if you take the whole cutting tool, this part is the one which will be actually important in the total material, or which will be acting or which is important for the material removal process. Now in this particular thing, there should be a support. Like since in the machining, as we have discussed, in a conventional machining process, the amount of forces which are developed are much higher. Now since the amount of forces developed are much higher in the process, the tool should be able to withstand these forces during the machining process. Now, to withstand these high forces, this tool shank is the one which will be acting like a supporting, which acts like a support to the tool, the part which is actually participating in the cutting process. Now, if you take the next one, the nose radius, why do we provide this nose radius? Why are we not providing this part as a sharp corner edge? Now, the reason for providing this nose radius, or why there is no sharp edge or a pointed edge at this point, pointed corner. The reason to provide this nose radius is to concentrate the area, the stress which is developed during the process. The area on which the amount of force which is acting during or which is generated during the process will be concentrated in this area. By providing this nose radius, we are increasing the concentration area on which this part, the amount of forces falling on this thing, by which we are increasing the life of the tool, will be increased. Okay, so multi-point cutting tool is nothing but it is a combination of number of single point cutting edges. So now, if you take the common different types of machining process or the common types of machining process, now in this we have turning process, where this is the basic process where from a cylindrical rod, if you want to remove the material, we will be using a turning process by using a single point cutting tool. If we do the process by using a single point cutting tool, then it is called as a turning operation. Now we'll be discussing about this turning operation in much detail in the next coming slides. For now, the basic type of machining process, one of which is turning process. By using a single point cutting tool, if you remove the material from a cylindrical rod, then it is called as a plain turning process. And if you are using a two cutting edges, if two cutting edges are participating in the material removal process, then we call it as a drilling operation, where two cutting edges will be participating in the material removal process. Now in this present figure, now this drill bit is used to machine holes. Drill bit is the one or the tool in a drilling process which we use is a drill bit, which has two cutting edges which will be participating in the material removal process. Now, this is mainly used for drilling holes. And if you take now the above process, like in a turning operation, this can be applied for the workpiece is cylindrical. Now, if you want to remove the material from a square block, then we go for a milling operation where multi-point cutting edge tool is used. Now, the tool used in a milling operation is a milling cutter. It is called as a milling cutter. Now, in milling, there are two types of milling operations, that is peripheral milling and face milling. These two are classified based on how the teeth are present or where the teeth are located. Now, we'll be discussing about these two in much detail when we discuss about the milling operation. Now, here from a cylindrical work part, if you want to remove the material or if you want to reduce the diameter or reduce the length of the cylindrical rod, then we go for a single point cutting tool. We use a single point cutting tool and we use a lathe machine. Whereas if you want to remove the material from a square block, then we go for a milling operation. Now, these are the common types of machining process in a conventional machining process. So now, if you take, like when we are going for machining the surface, when we are removing the material from the surface, now you can see the material which is removed is called a chip. Is called a chip. So these chips are classified into two types. The chips or the material which is removed, the unwanted material or the material which is removed from the surface of the component to obtain a final component, desired component, that is called as a chip. Now there are two types of chips, that is discontinuous chip and a continuous chip. If you are machining, like while machining, if you observe, um, when you are machining, if the chip is continuous, then we call it as a continuous chip. Or now this kind of continuous chips are obtained in while machining a ductile material. While machining a ductile material, these kinds of chips can be observed. Whereas discontinuous chips are observed while machining a brittle material. Like for example, if you take all of you must have done the workshop. You have machined a mild steel rod. While machining that mild steel rod, you might have observed the chips which have come out. Those chips are very long, right? Those chips are long. Those are called continuous chips. And if you have observed any machining of any glass surface, if you have observed any time machining or removal of uh, material from a glass surface, or uh, when you are try to cutting in large hilly areas, they'll be cutting stones. While cutting that stone, you observe, you will be not saying that the material which is removed will be in a continuous form. It will be in a irregular shape, that is discontinuous, a small powder kind of output which you will be observing. Now those are called as discontinuous chips. While also in machining a glass, you might have observed the glass will not be giving out a discontinuous chip. It gives the chip in the form of an irregular shape, broken chips. Those are called as a discontinuous chips. Right? So in a brittle material, you will be observing a discontinuous chip, whereas in a ductile material, you will be observing a continuous chip. Now, if you take the classification of machined parts, how do we classify different types of machined parts? Like as we have seen the different types of machining operations, like here You have seen a cylindrical rod will be machined in a lathe, whereas plain surfaces will be machined. Like the final output, here we have to consider the final cross section that has to be obtained. Depending on the final cross section of the component, you can see or you can obtain the shape of the component, right? So if you see the different parts, machined parts that can be obtained. Now these classifications are, or there are two factors by which we classify these operations. Like the first one is between, if there is the relative, those are generating type. The first type is a generating type where the relative motion between the tool and the workpiece will determine the shape of the component that is obtained. In the second type, that is a forming type, depending on the shape of the tool that is used, we get the final component, right? So now machining operations can be classified into or classified based on two factors, that is generating type and forming type. Generating type, depending on the relative motion between the tool and the workpiece, you get the final output of the component or final shape of the component. Whereas in a forming type, depending on the shape of the tool that you have used, you will be getting different shapes of the final component. The final shape of the component will be depending on the or dependent on the form of the tool. Like for example, if you see these are some of the examples of generating type where in a like the straight turning, taper turning or contour turning. Now the tool used is the same in all the three types. In all the three types, straight turning, whether it is a taper turning or a contour turning, if you take all the three types of turning operations use a single point cutting tool. But the final shape of the component here obtained is different. That is because it is dependent on how you give the feed. If the feed is parallel to the workpiece axis, you get a straight turning operation. Whereas if the feed is at an angle to the workpiece axis, then you get a taper turning. Whereas contour turning is irregular, like it is not constant. In the first two, it is constant. The feed which is given is constant. Whereas in this, it is not constant at a certain shape, right? So now whether it is not dependent in a generating type, you can say that here the final shape of the component is dependent on the feed you give. Feed or the relative motion between the tool and the workpiece will determine the final shape of the component. In the same way, in a milling operation also, you can observe the same thing. Now these are some of the generating type of operations. Like next type or the next factor, if you see, forming type. Now the forming type is, now as we have discussed earlier, in a form type the final component shape is dependent or will be dependent on the shape of the tool that is used. Like here if you see, now the shape of the tool in a form turning operation, the shape of the tool is a certain shape which is given here. Depending on this, you get the shape on the surface of the final component. Whereas in a drilling operation, now the shape is determined by the shape of the tool. You get the hole. In the same way, in a broaching operation also, depending on the shape that you provide, the keyholes, all these will be obtained in a broaching operation. Now, this type of machining type is called as forming type, where the final component shape is dependent on the shape of the tool that is used. And there are other types. There is other type where we use combination of these two, forming and generating type. Whereas here, now in this present thread cutting operation, in this particular thing, you can see the shape of the thread. Now this is a thread cutting tool. Okay, this is a thread cutting tool. Now we provide this V shape to this tool, which determines the thread, which will give you the thread or the type of thread that has to be obtained. And the feed motion here, we give large feeds here in a threading operation. The feed motion will be determining the shape of the final component. The type and shape are obtained by the combination of both forming and generating type. Now this is a thread cutting operation which comes under a combination of forming and generating. And in a slot milling also, the slot, this one will be determining the tool. Slot milling cutter will determine the slot or the shape that has to be obtained, whereas the production of the slot is determined by the feed which we give. So it is dependent on both the shape of the tool and also the feed which we are providing while machining. So this is a combination of both, right? So now, as we have discussed, those are the different types. And coming to the turning operation, or the first foremost operation, or the basic type of operation which we will be seeing is a turning operation. Now, everyone has done workshop practice where you have seen a turning operation where the basic we'll be using a cylindrical rod. Cylindrical rod. Here D naught determines the initial diameter of the rod, whereas DF determines the final diameter of the rod. And we are using a single point cutting tool here to removing the material from the surface. And like here, the cutting tool will be uh, the the feed is given to the tool, and the workpiece will be having a rotational speed, or we call it as a cutting speed. Now, as we have discussed, like turning operation, now we are cutting the material here. Now, since we are cutting the material, there are certain conditions which we have to use, right? So, when every operation, whatever the operation which you take, every operation will be subjected to certain conditions. We have to follow certain conditions. Now, what those machine here in this particular operation we are doing machining operation, so here we call it as a machining conditions. Those are called as machining conditions. Now what are the different machining conditions or the machining parameters? Now here in this, when we are doing the machining, we use certain parameters. There are three main parameters for a machining operation, that is cutting speed, feed and depth of cut. Now, if you take cutting speed is, how do we define these terms? Cutting speed is nothing but the speed at which the workpiece rotates, or the cylindrical rod rotates. The speed at which the workpiece rotates is called a cutting speed. Whereas feed, how do we define feed? Feed is nothing but it is the tool movement parallel the tool movement per one revolution of the workpiece, or the distance moved by the tool for one revolution of the workpiece. It is called as feed. Now here in this particular case, the tool will be moving in this direction. Now, at the same time, the workpiece will also be rotating. So, for one rotation of the workpiece, this tool will be moving a certain distance. Now, that distance we call it as a feed. And what is this depth of cut? Depth of cut is nothing but the distance moved by the tool into the workpiece. The distance moved by the tool into the workpiece. That is called as depth of cut, or the amount of material that has to be removed. That is called as depth of cut. So these are the three parameters parameters on which the machining will be dependent. It is dependent on these three parameters. Now, by varying these three parameters, we can control the machining operation. By varying these three parameters, we can control the machining operation. Now, as you have seen, like while doing the machining operation in the lab, you might have observed, like by increasing the feed, by if you have moved the tool very fast, the amount of chip that has obtained will be very thin, and by giving more depth of cut, the amount of material removed will be much higher, right? And also the amount of heat generated will also be much higher. And by increasing the cutting speed, you can get a more finer cuts, right? So these are the three parameters by which the machining operation will be dependent. By varying these parameters, we can get different machining conditions, right? So the machining operation is whether whatever it is, the machining operation will be dependent on these three parameters, right? So now if you take this coming to the turning operation, now turning is the process in which the tool moves, in which the tool will be moving perpendicular to the workpiece axis, right? Perpendicular or parallel? It is parallel to the workpiece axis, right? Now there are different turning operations you might have observed, right? Some you might have done, some you'll be seeing now. Now there are different types of operations. Now the first operation, if you see, is facing operation. Now, what is the difference between a plane turning operation and a facing operation? If you take a plane turning operation, the tool movement is parallel, or tool movement or the feed direction is parallel to the workpiece. The feed is given parallel to the workpiece axis. Okay, we define here, or we define these operations based on the workpiece axis and the tool movement or tool direction. If the feed is parallel to the workpiece axis, this is the workpiece axis. If the feed is given parallel to the workpiece axis, then it is termed as a turning operation. Now, if the feed is given perpendicular to the workpiece axis, then it is called as a facing operation. If the feed is given perpendicular to the workpiece axis, then it is called as a facing operation. And if you take taper turning, if the feed is given angle, at an angle parallel to the workpiece axis, then it is called as a taper turning operation. If the feed is given at an angle parallel to the workpiece axis, then it is called as a taper turning operation. Now, contour turning is nothing but where the feed is not constant throughout the axis. It is parallel, but it is not constant throughout the movement. Like here in the earlier cases, that is facing or taper turning, or it is a plane turning operation where you see we'll be giving a constant feed. Feed is constant during the process, whereas in a contour turning, if the feed is not constant, it is not constant during its movement. This we'll be seeing in the video. Whereas form turning is nothing but if you provide a form to the tool and you do the machining operation, then it is called as a form turning. The opposite of this profile will be imparted on the surface. This is a forming type of operation, right? Now, the form which is provided on the tool will be produced as an impression in the opposite direction in the workpiece surface. And if you take the chamfering operation, it is nothing but removing by using a single point cutting tool. You remove some of the material from the edges. That is called a chamfering operation. And part of or cut off operation is nothing but you just cut the given rod into two parts by using a tool, a special tool, cut off tool or a part of tool. By using this tool, you just cut this into two parts. that is a cutoff operation. Whereas threading operation is nothing but producing threads on the external threads on the surface of a cylindrical rod. Right? There are other operations. Before going to these operations, I want to show you a video where you can see the video.
In straight turning, the tool is fed parallel to the axis of the work to reduce its diameter so that the final diameter is the same at each end. Removing a significant amount of material in one pass is called rough turning.
This present operation is a plane turning operation. Now this is a single point cutting tool which is removing the material from the surface. That is a plane turning operation. This is a taper
Center line
operation.
or by using a taper attachment. Short, steep tapers can be turned using a compound rest. Contour turning or profiling was.
Now here you can see the tool which is feeding, the feed which is given to the tool is not constant throughout the surface. It is producing a certain shape on the workpiece surface. Now this type we call it as a contour turning operation.
In which the desired contour is simply programmed into the machine, which directs a cutting tool to cut the contour. Forming is another alternative for generating complicated shapes. The tool having the desired form or geometry is advanced perpendicular to the axis of rotation, reproducing the tool shape in the workpiece. Forming is commonly performed on automatic screw machines. Chamfering eliminates sharp corners from a workpiece and is a good safety measure. Typically, chamfering breaks corners at a 45-degree angle. Grooving creates a groove or recess using a tool that is usually the size and shape of the required groove.
If we have to produce a certain grooves on the surface, the earlier operation is a grooving operation. Okay, so these are some of the operations by which if you take this present operation, that is a thread cutting operation, where you can see the formation of threads. So the external threads can be obtained by using this operation. Now here you can see it's a combination of both generating and forming type, where the shape is given by, or the thread shape is determined by this, and the formation of the threads can be obtained by the feed motion of the tool. Here in this present operation, the feed is given to the workpiece. Right. Now coming to the other operations which are related to turning operation, you can see the drilling operation, boring operation, and knurling operation. Now drilling operation is nothing but producing hole in a internal holes in a cylindrical hole. And if you take the boring operation, in a boring operation, it is used for enlarging the holes. Now we'll discuss much detail about boring in the next coming slides. And if you take the knurling operation is the only one operation which is a kind of forming operation. It is not a machining operation, it is a forming operation where the impression on the tool will be impressed, or the shape of the workpiece will be deformed. The impressions will be imparted by deformation process on the workpiece surface. Now this is a knurling operation. And then if you take the lathe, engine lathe, or the basic turning operation, whatever the operations which you are seen, all these operations will be carried out on the lathe machine tool. Now this lathe machine tool, the main important components of this lathe machine tool are headstock and tailstock, where on a headstock the spindle will be attached to it and the control will be given by a speed control. The motion to the workpiece will be provided by the speed control. And then we have lead screw, or the carriage on which the cross slide will be mounted, and onto this cross slide the tool post will be attached. Now tool post is the one which holds the tool, where the tool will be fixed, whereas spindle to which the workpiece will be attached, or headstock to which the workpiece will be placed by using attachments. And then we have the main use of tailstock is for a larger length workpieces. If the length of the workpiece is very large, then this tailstock will be acting like a support to the large workpieces. It will be acting like a support. Whereas it can also be acting like a centering point. If you are drilling, this can also be mounted with a drilling tool and we can perform the drilling operation. And lathe bed, which is very sturdy, that will be made in such a way that it takes all the vibrations during the machining process. It is very sturdy support which will be acting like a support to all these elements. And guideways are those on which this carriage will be moving. So for the feed will be provided, the carriage will be moving in the forward direction, forward or backward. It will be moving in the parallel direction to the workpiece, whereas cross slide is the one which will be moving for feed which is provided in the perpendicular direction. For feed in the perpendicular direction, we give it to the cross slide, whereas carriage is the one which will be providing the feed in the parallel direction to the workpiece. So now here we'll see a small video on this.
dimension of the boring tool dimension. First we make the drilling, next we are using the boring tool itself, we do the boring operation. Just observe this. First we want to make the drilling. Then we are doing the drilling operation after the
In this present case, he is performing a drilling operation. This is a boring tool. You can see this is a single point cutting tool. So now the first drilling operation has been performed, and then a boring operation is being performed to enlarge the existing hole by using a single point. Okay. Now coming to the different types of boring machines. Like here we have boring different types of forms. How do we do the boring operation? The present one what you have seen is the workpiece will be rotated and the tool will be given feed motion. This is one type of boring where the work part will be rotating and the feed will be given to the boring bar. Whereas in the other type where the work is fed into a rotating boring bar bar will be rotating, whereas the workpiece will be fed into it. The feed is given to the work part. Now these are the different forms of boring operations. Now if you take, now those two are like as we have discussed, depending on the length of the workpiece. If it is large compared to the diameter, we go for a horizontal boring, and if the diameter is large compared to the length of the component, then we go for a vertical boring machine. Now those kind of workpieces can be machined by using a vertical boring machine. Now uh, this is a vertical boring machine where you can see the feed motion, or the it has a z direction motion, and it has a x and y direction motion, and it also, the work table can also have a rotary motion. Now these are the different parts. The cross rail on which the tool head will be given x and y motion, and the work part which is placed on the work table which will have the rotary motion. Okay, and we have side tool head to for placing the tool, which has a side motion and a side column, and these are the different parts of a vertical boring machine. Now, this is the end of the presentation. In the next session, we'll discuss about drilling and milling operations.